Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn about recursion, which is a different way of doing loops or just running logic multiple times. Okay, so recursion. This sounds like a really fancy word, but in terms of logic it's really super simple. It really just means a function that calls itself. So for example over here, let's make a function, so private static void, let's call it test recursion. So we have this function which does some kind of thing, and then inside this function we call itself, and up here we call the first function. So yep, that's it. This is recursion. It's pretty much just a function which inside calls itself. Now, right away you might be able to tell a big issue here. You can probably already tell that this is going to be an infinite loop, since this function will call itself for infinity. And actually, if we try to run this code, we actually get a fun piece of trivia. Yep, here we have an infinite loop that eventually ended, and it ended with this error, a Stack Overflow exception. And yep, this is where the famous website got its name. Basically, as you call functions, your CPU stores references to those functions in something called a call stack. That's a stack of all the functions that have been called in the current process. The CPU needs to know that so that it knows that when a function ends, where should it jump back to. But of course, memory has a limit, so if you call a function within a function way too many times, eventually you reach that maximum, which then causes the stack to loop back, which in turn is called a stack overflow. So with this code, we have an infinite loop, not very useful. But like we already saw in the last lecture and in the beginner section, loops can be extremely useful. And recursion is really just one type of loop. So with recursion, we can do literally anything we can do with normal loops. For example, let's write a while loop. Let's increase some kind of number one by one until 5. So here we have a simple while loop, so we define number of 0, and while the number is under 5, we just increment it. So that's it, pretty simple. Now let's do the exact same thing using recursion. So on this, we have a function. And really, since recursion is all about a function calling itself, all we really need to do is pass in our variable as our parameter. So we can just receive an int for the number, and inside do number plus plus. However, just like this it won't work, since like we saw on the lecture on scope and functions, function parameters are actually local variables. So when we call this function with this, we're working with a copy and not the original data. So to get some kind of result back from our function, let's simply set it as our return type. So let's return of type int. And then here we can do our logic and basically then do return number in order to return the final number. So now when do we want to return the final number? So now let's do the same condition that we had up there. So if number is under 5. So we do if number is under 5. If so, then we're going to call test recursion again, and we're going to return it with number plus 1. And in order to get the data back, let's call a return on this. And if not, if the number is above or equal to 5, if so, let's just return the regular number. So just like this. Let's just give this a proper name, so let's rename this to recursion incrementer. Then up here, let's call the same thing, and we're going to start off by calling it with number 0, and let's do a console.writeLine on this to see the result. So let's see the result on this one, and also a console.writeLine on the other number made with the regular while loop. Okay, so let's see if both these do return 5, and if there it is, they both return 5. So we both have this logic that this one is going to run this logic multiple times, and this one is also going to run the same logic multiple times. So over here, as we call this, the first time number is going to be 0, and if number is under 5, if so, then this one is going to return the result of this function, and this function call will pass in the number, so 0 plus 1, pass in number 1. So once again, that is going to go inside this function, now with the number 1, which again, still under. So it is going to return another call of this function, which again, with the number 1 plus 1 equals 2, and so on. And as soon as it gets to 5, just returns the final number. So basically here we are stacking multiple function calls on top of one another, and when the final one returns, they all basically return and the call stack collapses and we end up with the final result. Then if we wanted, instead of having a hardcode maximum over here, we could have another one as a parameter. So an end for the number max. So we have that and we receive it here and we just pass it along the same way onto the next function call. And then we could also have a parameter for the incrementer, so increment amount. So we have this one, and instead of increasing by 1, we increase by the incrementer amount. So then over here, let's put it 5 and then 1. And over here, let's also pass in the incrementer amount. And yep, same result, 5, 5. And what we have built here is essentially the exact same logic as some kind of for loop. If you remember, the for loop has some kind of initializer iterator variable. Then it has some kind of condition, usually some kind of maximum number, and it increments by a certain amount. So what we have here is literally the exact same thing as a for loop, except it's being handled with recursion. So all the logic you can do with any kind of loop, you can do with recursion. This is really just an interesting way to handle running logic multiple times by simply being very clever about how a function can call itself multiple times. Now, I should also say that personally, I'm not really much of a fan of recursion. In general, I find it needlessly confusing. I much prefer to have a simple for loop where I can very easily see the iterator and the end condition, as opposed to having to look at the parameters for a function and trying to guess when it will stop calling itself. So personally for me, I pretty much never use recursion. I always use just regular loops. I find those much more straightforward. But recursion is a valid option, so I definitely wanted to cover it, especially if you're into advanced mathematics. If so, then you might actually like it, since mathematics has a lot of this kind of stuff. If you like that, then perhaps for you recursion might be much more natural, much more intuitive than working with regular for loops. Just always be careful, the same issue with for loops, which is always be careful not to end up with infinite loops.